All right, so fundamental theorem of calculus says if a function f is continuous from a to b, and then they do this thing with this capital F. Capital F is the antiderivative of f on a to b. Then your integral from a to b, f of x dx, is capital F of b minus capital F of a. So what that means is you do the antiderivative, and that's what the integral means. That's what this symbol means, is do an antiderivative, but you don't put a plus c at the end because this is a definite integral. Remember, definite means it has boundaries, indefinite means it has no boundaries. So if there are boundaries, you don't put a plus c, you want to get an actual numeric answer for the area under the curve. So you do the antiderivative, that's the capital F, and it's upper boundary minus lower boundary. Which makes sense. If you're trying to get the area in between, it's like you do the upper minus lower, and that's going to give you the area in between. So you do an antiderivative, and then it is upper boundary minus lower boundary. Now, how far are we going to simplify these? So if it is free response, you can just leave your answer alone and walk away. But if it's multiple choice, you have to be able to simplify it down. So simplifying is an important skill. So here's what I'm going to do for all these. If it seems relatively easy to simplify down, we're going to keep going. And if it's a complete disaster, then I'll let you stop. So like use your common sense there. Okay. So for this first one, we're going to do the antiderivative of x squared, which would be 1/3 x cubed. Again, don't put a plus c. That's for an indefinite integral. We want to actually find this area under the curve. So you do the antiderivative, and then you put this bar, which means such that 0 to 1. So once you do the antiderivative, you don't need the integral symbol anymore because you've done the integration. That's what the antiderivative is. It's such that 0 to 1, and then we're going to do upper boundary minus lower boundary. So if we plug in 1 for x, 1 cubed is 1 times 1/3 would be 1/3 minus, and then we're going to do the lower boundary, which if you plug in 0 to this, you're going to just get 0. So it was plugging in the upper boundary minus plugging in the lower boundary, and so that just gives us 1/3, which if you remember back to the notes we did a couple of days ago, this was the very first example we did with those Riemann sums. We did the graph was x squared, and we did the area under the curve from 0 to 1. And remember, I showed you how to type it in the calculator too. Let's review that. Do you guys remember where to get the integral in the calculator? Because I'm showing you how to work them out by hand now, but you do need to know how to type them too. Does anyone remember where they said math 9? Oh, good job, guys. Math 9. Math 8 and math 9 are the two that you want to know. Math 9 you're going to get to use a lot more often. If you forget, it says int for integral. All right, so math 9, and it was 0 to 1 x squared dx. And it comes out to 1/3, which shows 0.3 repeating, but that is 1/3. All right, so let's try another one. So we're going to do the antiderivative and then upper boundary minus lower boundary. So antiderivative of 4x. We need a function that if we did the derivative, we would get 4x. Like 4x is the answer. All right, so what do you guys have for me? What would be the antiderivative for 4x? All right, good, awesome, perfect, 2x squared. So if you did the derivative of 2x squared, you would get 4x, and it is such that 0 to 1. So upper boundary minus lower boundary. If we plug in 1 squared is 1 times 2 is 2. Minus lower boundary, now if you plug in 0, you're going to just get 0. And so that answer is 2. So the area under that graph from 0 to 1 is 2. All right, so here, antiderivative for x squared, that is going to be 1/3 x cubed. For x, that's going to be 1/2 x squared. And then for -1, that would be just -1x. Again, you can always check your work. If you do the derivative of this, you're going to get what's here. This is such that -3 to +3. So we're going to do upper boundary minus lower boundary. All right, so first we're going to plug in this +3. All right, 3 cubed is 27. 1/3 of 27 is 9. plus, all right, 3 squared is 9 and then halves. So plus 9 halves minus 3. So that's upper boundary. Minus lower boundary. Now if we plug in -3, that's going to be -27, and then a third of that would be -9. -3 squared would be 9 and then halves, so plus 9 halves. And then if I plug in -3 here, it would be minus -3, so plus 3. Now, again, if it's free response, you could stop here and that would just be your answer. Let's keep going with this one though. Again, if it's not too terrible, I want us to keep going because say this was non-calculator and it was multiple choice and you had to be able to pick an answer choice. Right? So 9 minus 3 would be 6. This first part is 6 plus 9 halves. And then what I'm going to do is distribute this negative into those parentheses. So this will be plus 9 minus 9 halves minus 3. And so the 9 halves are going to cancel out, which is nice. We have plus 9 halves minus 9 halves. So 6 plus 9 will be 15, minus 3 would be 12. And let's just, if you have a calculator handy, let's go through typing that one in as well, because you know they're both important skills, being able to do this by hand and being able to type it in. I put this, we can see it better. All right, so if you type this original problem, math 9, -3 to 3, x squared plus x minus 1 dx. And so we should get 12, which we will because we didn't mess up at all. So that will give you your answer. All right, so for this next one, I'm going to rewrite the problem first before I do the antiderivative because I have this 2 over x squared. So I'm going to rewrite that as 2x to the -2. Remember, when you divide, that's going to make your exponent negative. And then there's this plus x dx. And let me bring this up because this is a common mistake that happens with things like this. Do you remember the one that we did that was 1 over x dx? What was this? What did this one come out to? Because we did this one last time. Yeah, so that's ln. And I'm sorry, hold on one second, guys. All right, so if you have 1 over x, that goes to ln. And nicely remembered. Oh, and someone put the absolute value in there too. Nice, absolute value x. But if you have 1 over anything else, it does not equal ln. So if you have 1 over x squared or 1 over x cubed or 1 over x to the 4th, those don't equal ln. It's only 1 over x, okay? Because this is a common mistake is people will put like a ln of x squared. Don't do that, okay? So I'll show you how this is actually going to work out. I rewrote it as 2x to the -2, and we're going to go through the antiderivative the same way that we did this one. You add 1 to the power, and then you divide by that. So just be careful because it's negative. If we add 1 to this power, it's -2 right now. If I add 1 to that, it's going to be -1. It's like it becomes less negative. And then we want to divide by a -1, which is just going to make this negative. And again, you can always check your work by doing a derivative. If you did the derivative of this, you'd multiply down the -1, negatives would cancel, it would be a +2, and then you would subtract 1 from the exponent, which would make it -2. So if you do the derivative of this, you will get this. All right, plus antiderivative for x is 1/2 x squared, and such that 1 to 4. Now I am again going to rewrite this. I want to fix the negative exponent before I start evaluating here. -2x to the -1. How could I rewrite that so I don't have a negative exponent? I want to rewrite that so that I don't have x to the -1. Good, it's going to go down to the denominator. Good, nice job. So it'll be -2 over x plus 1/2 x squared from 1 to 4. All right, so I did a little bit of rewriting there because I wanted to fix the negative exponent. And now we're going to do upper boundary minus lower boundary. All right, so if we plug in 4, -2 over 4, that would be -1/2 plus 4 squared is 16, half of that is 8. So that's the upper boundary. minus lower boundary, if we plug in 1, that's going to be -2 plus a half. Now this one's not too bad, so I'd like for us to keep going. Again, if it's a total disaster, I'll let you just stop, but this one's not going to be too bad. Let me distribute the negative sign. This is going to be -1/2 plus 8 plus 2 minus a half. So 8 plus 2 is 10. Minus a half and minus a half would be -1, so the total answer is going to come out to be 9. And if you wanted to check it in your calculator, you could. All right, so for this one, I am also going to rewrite this. I'm going to take this 1/4. Do you see how this is all over 4? The whole thing is over 4. I'm going to take that 1/4 and put it outside of the integral. Again, you're allowed to take a coefficient and put it out front. You can never put a variable out front, though. But since this whole thing's over 4, I'm going to put that 1/4 out front. And then we've got x plus square root of x. So I'm going to write that as x plus x to the 1/2. Again, a square root is to the 1/2. A cube root would be to the 1/3. A fourth root would be to the 1/4 power, so on and so forth. All right, so now we're going to do the antiderivative, and it's just going to have a 1/4 sitting out front. So it'll be 1/4 times, all right, antiderivative for x is 1/2 x squared. And then this antiderivative, this is going to be fun with fractions here. It's going to do the exact same thing. You're going to add 1 to the power. So 1/2 plus 1 would be 3/2. And then you have to divide by 3/2, which means we're going to put a 2/3 out front. It's the reciprocal. So again, I added 1 to this power. 1/2 plus 1 is 3/2, and then I divided by that. I put a 2/3 out front. And then such that 1/4. So this is going to be upper boundary minus lower boundary. All right, if we plug in 4, that is going to give us, let's see, 4 squared is 16. Half of that is 8 plus 2/3. And then this would be a square root of 4 cubed. The denominator tells you what type of root it is. So it's a square root, and then 4 cubed is 64, which I guess actually that whole thing would end up being 8. Minus, all right, now we're going to plug in 1 to this whole thing. So that'll be 1/4. And then if we plug in 1, that's going to be 1/2 plus, now 1 to any power is just going to be 1. And then times 2/3 would be 2/3. Now this is an example of one where we're going to just stop. Like it came out to a complete disaster. Now square root of 64 is 8. So you could, that could be 8, and then 8 times 2 is 16. But like this is just a gigantic mess. So I'm going to go ahead and just let this be our answer for that one. Which again, on free response is totally fine. You can just completely leave that answer alone. All right, so we need an antiderivative for 2x to the third. So for the x to the third, again, I'll usually just ignore the coefficient and do this and then multiply it back on. This would be 1/4 x to the fourth. But there's a 2 out front. So instead of 1/4, it would be 2/4, which is 1/2. Minus e to the x is itself, and then such that 1 to 3. So if we plug in 3, upper boundary minus lower boundary. So 3 to the fourth is 81. So this would be 81/2 minus e cubed minus, and then we're going to plug in 1. So if we plug in 1, we're going to get 1/2 minus e. So there's not much we can do to that, but we can at least combine these fractions. If you have 81/2 minus 1/2 here, let me distribute the negative. You have 81/2 minus 1/2, that would be 80/2, which is 40. So this would be 40 minus e cubed plus e. That's not a very good spelling. All right, this next one is trig. We need to come up with a trig function that has this as its derivative. Let me grab my note cards here. All right, we need a trig function that has cosecant, cotangent as its answer. So here's the one that we're looking at. Derivative of cosecant is negative cosecant cotangent. So since we want it to be negative, it doesn't match quite exactly. We just need a negative in there. So I'm going to have it be negative cosecant. So negative cosecant is our antiderivative. All right, and so it is going to be upper boundary minus lower boundary. So we're going to have negative cosecant of pi over 2 minus negative cosecant of pi over 4. And then we're going to evaluate these. All right, so let me pull out my unit circle. Here's the unit circle. Where is pi over 2? Is it up, down, left, or right? Where is pi over 2 on here? You can just type up, down, left, or right. Good. I'm hoping for more answers there. You guys are sleepy today. Up. Okay, this is pi over 2. Nice job. All right. Cosecant is the reciprocal of sine, and sine is the y value. So sine of pi over 2 is 1. Cosecant means we're just going to flip that. Well, 1 over 1 is 1. So that would be 1. Good. And so we're just going to make it negative. So this would be negative 1. All right, now I can't use this for the pi over 4. I'm going to have to draw a triangle for that. Pi over 4 would be right here, and the sides of the triangle would both be root 2 over 2. Yeah, good, nice job. Perfect. All right, so again, we're going to flip the y value. If you flip square root of 2 over 2, you just get square root of 2. You can do that if you want and rationalize it. You get 2's everywhere. Just trust me. If you flip this, you just get square root of 2. And we're going to make it negative. So negative square root of 2. And then those negatives cancel. So it'll be negative 1 plus square root of 2. So that was your little review of trig. All right, and then find the area bounded by these graphs. All right, well, let's draw a picture of this. E to the x is going to be a swoop. So it's going to do something like this. X equals 0 is right here. X equals 2 would be right here. And then y equals 0 is the x-axis. So this is the area that we're looking for. All right, so just instead of setting up the integral for us, we had to draw a picture and we have to set up the integral ourselves. So hey guys, what are going to be the boundaries on the integral? We're going to integrate from where to where? Yeah, perfect, good, from here to here. So 0 to 2. We want the area under this function, which is e to the x, and then dx. And you want to be like, thank you, hallelujah, because this is the easiest one to deal with. It is itself. So it's e to the x from 0 to 2. So we're going to do upper boundary minus lower boundary. And e to the 0 is 1. Anything to the 0 power is 1. So this is e squared minus 1. And I'm going to just do the next one on the back before we do our break, because that'll stop right before we get into average values. So let me just go ahead and do this next one as well. It's the same idea. We're going to have to draw the graph ourselves and then set up the integral. All right, so find the area bounded by these graphs. All right, this first one, it's a line moved up 3, and it's going to have a slope of 3/2. Just as a heads up, this graph is going to need to go up pretty far when we do the next graph. I can't remember exactly how far, but 8. It's going to have to go up to 8. I remember this graph went up kind of far here. So leave yourself enough room. All right, so we're going to go up 3, and then our slope is 3/2. So we're going to go up 3 over 2. All right, and then this one is an upside down parabola moved up 8. So I'm going to go up 8. I hope I left enough room for that. 7, 8, okay, good. And I know it's going to do something like this. But I just want to plug in some numbers because I've got this 1/2 in here that's going to shrink it. Now I'm going to not plug in 1 because I don't want to deal with plotting a fraction here. So I'm going to go ahead and just plug in 2. All right, so if I plug in 2, 2 squared is 4. Half of that is 2, but it's negative. So -2 plus 8 is 6. So I get 2, 6, which is going to be this exact same point here. And then I just didn't plot it very well because I don't have an axis here. That is 6. I'll just make the point bigger. And then you're going to get the same point on the other side because it's going to be a parabola. All right, and then let me plug in, I don't want to plug in 3 because again, I don't want to deal with a fraction. Let me plug in 4. 4 squared would be 16. Half of that would be 8, but it's negative. So -8 plus 8 would be 0. So I'm going to get 4, 0. And same thing on the other side. So here's our parabola. And so we want the area bounded by those graphs and the x-axis. All right, so this is the area that we're trying to get here. So we're going to need to break this at the intersection and do 2 separate integrals, right? We're going to break this at this intersection, which is happening at 2, and we're going to do 2 separate integrals. I had you set up one like this before. We did one like this before. We just didn't continue working it out. I gave you the graph and we set up 2 separate integrals where there was a discontinuity. There's no discontinuity here, but it's the same idea. Why isn't it the other side? If you get a choice, you want to pick the positive side. Also, this area would be like really strange. They typically mean the positive side or they would give you a graph. Okay. You want to pick the less confusing of the two, basically. All right, so for this one, we want to go from -2 to +2. So this is going to be integral from -2 to +2. So right here, and that is the area that's under the line. So I want to use this equation. So 3/2 x plus 3 dx. So that's for this first part. Here, let me color code these. So from -2 to 2, doing this area, we're using the line. And then plus the next integral is going to be from 2 to 4. And that's the part that's underneath the parabola. So we're going to use this equation. All right, I won't make us evaluate this one the whole way out, but I do want to do the antiderivatives, okay, because that's the part that we need to practice. So for this one, antiderivative of x would be 1/2 x squared, but there's already a 3/2 there. So if you multiply that by a half, you're going to get 3/4. So 3/4 x squared plus antiderivative of 3 would be 3x such that -2 to 2. And then this one, for the x to the 1/2, it would be 1/3 x cubed, but there's already a -1/2 there. So if you multiply -1/2 times 1/3, that's going to be -6. And then antiderivative of 8 would be 8x, and that's such that 2 to 4. It's like 2 totally separate problems, like part A and a part B. All right, so if you did upper boundary minus lower boundary, I'm going to let us just leave this one completely alone. You could do 3/4 times 2 squared plus 3 times 2. That's plugging in your upper boundary minus, and then you can plug in your lower boundary. And I'm not joking, on the AP exam, you can totally leave it like that and they'll accept that as the correct answer. Just plug in 2 minus, plug in -2. And then for this one, we're going to plug in 4 minus, and then plug in 2. The only thing is, it's a lot of parentheses, and I almost ran out of room. There we go. All right, so upper boundary minus lower boundary, and then we did plus, and then I did upper boundary minus lower boundary. I plugged in the 4, and then I plugged in the 2.